First, very shortly, ITAVI, so as I told you, Technical Institute, we have 3 principal missions. To be a technical support for fish farmers, to make applied research, and to make a lot of diffusion, valorization of our result. So it's in different fields, revolving around aquaculture, so fish farming, and more recently algoculture with, for example, spirulina, where we are working with also with Canourge on this kind of project. And more recently, we developed also some design services for aquaponics system for French project holders. So basically, ITAVI is supposed to be a kind of interface between education, research, I mean fundamental research like INRA, IFREMER, maybe you know these institutes, the profession, which means fish farmers, but also regional and national organization, also feed manufacturers, and the administration. So ITAVI is kind of in the center of all that to make people speak to each other, I would say. Now, a little bit about APIVA, the R&D project. So it's a French project. It began in 2013, and it will end at the end of the year. So we'll make a big seminar in Paris to share our results with people interested in this thematics. So what is APIVA? The goal of APIVA was to test different kind of systems in aquaponics with warm water, cold water, coupled or decoupled systems in an outside environment or a greenhouse environment with opened or closed RAS. I will tell you more about that a bit later. When I say open or closed, it's in terms of makeup water, so water renewal in the system. And also studies about the flux occurring in aquaponics with mass balance, for example, or life cycle analysis. So here are the partners. We have ITAVI, which is leading the project, Lycée Louis Pasteur, so it's where you are, the CIRAD, the Agronomic Research for the Development Institute, INRA, which is a national research for agronomy, the National Institute for Agronomic Research, and Astredor. Astredor is the same thing as ITAVI, but for the horticultural industry. So we are working each other together because we have different skills. Some of us are better in aquaculture, some like Astredor know a lot about plants and greenhouse. So that's why we make this consortium to work with each other. So in what context why we chose to work on aquaponics? So the world sees its population increasing a lot with a lot of urbanization. We have more and more modern productivist agriculture, and with the high consumption of chemical fertilizers, a large urban sprawl that can be a problem for arable land in some years. Also, the globalization of trades. More and more, because of this globalization, we have more and more claims of consumers for short food supply chain. So aquaponics would like to tend to go in this direction. And also the increasing demand for fish proteins. So if we listen to FAO, fish will have aquaculture will have a key role in the future for providing fish proteins. But it also have some problems like nitrogenous and phosphorus pollution and the water consumption that it can create. So we have the question of durability, and aquaponics and more largely maybe RAS can be a good solution for aquaculture development in the future. So you have to know that in France we don't have any RAS for the moment. It's really emergent. it's only open aquaculture, and more we try to communicate about RAS aquaponics to develop this kind of system in France, which is more developed in other countries. So the main goals of APIVA is to characterize compartments of aquaponics, to establish elements of sizing and technico-economic efficiency, to analyze the quality also of the products, the fish, but also the vegetables, in comparison with those coming from conventional systems. We try to monitor and optimize the fish agronomic, the plant's agronomic yield, but also the purification yield of the plants on fish effluents. So it's all about sizing. We modelize the environmental impact of aquaponics with life cycle analysis, and try to understand the flows occurring between the plant and the fish compartments with mass balance. And the main goal in all that is to transfer the acquired knowledge through education, colloquiums, or accompaniment, literature synthesis, and a clearing of all regulatory elements around aquaponics. So what has been done so far? Literature synthesis, mass balance modelization, epuration dynamic modelization of different elements. The life cycle analysis is not finished yet, but it's been doing. Also, the comparison between hydroponics and aquaponics in terms of yield, and also quality of the product. So that goes with nutritional test, also sensorial test, and sanitary test of the final products. We tested many different plants, and we have a first approach of a modelization software on RAS and aquaponics more largely. A first approach also of a technico-economic model. So there is not only one model, but many different models that we try to study in order to understand what should be the best if we want to have an activity which is viable. And we make a lot of communication and diffusion. And next, we have to make more publication. Sorry, I have a bee. She likes me. So this is some pictures of the structures we have in Astredor. It's where I am working. We have 130 square meters of raft. We have actually different technique. Raft, you can see here. Here is a kind of a pilot of bioclimatic greenhouse. I mean by that we have water in this box, and this water can accumulate the temperature. Well, there is a, sorry, I didn't plan to talk about it.
Maybe thermostat.
Sorry?
Thermostat maybe, which can stand the temperature in a specific degree.
Yeah. The goal is to stock the temperature in there to restitute it during the night. And we also have basic horticultural tables, which is working in ebb and flow, and 15 cubic meter of fish tanks. And also all about filtration. So I will talk to you later about that. Okay. So this is just a basic scheme about how is working the Rato pilot, which is the kind of the same that you will see in La Canourge. It is a coupled, decoupled system. It can be coupled or decoupled at will. So for now we have only tested it in a coupled configuration. But if we want, we can just stop the flows between the two compartments and work only with one or the other in case of problems. So we have the drum filter, we have the biofilter in MBBR. for the sludge, we use different technique. Here in La Canourge, they use vermifiltration. And in Rateau, so it's in Lyon, we are using geotubes, which are filtration bags where you can accumulate all the sludge and have a dry product that you can use later for in the field, for example, or for making another product with that. And we would like to try also mineralization, but we didn't test it yet. Okay, so just now I will show you some interesting preliminary result that we got in APIVA. So I mean preliminary, but because it's not published yet. So this is an example of what we do when we make a mass balance study. There you have all the inputs and the outputs of the system. So it's quite simple. For the input, we only have makeup water and feed. So this mass balance is for nitrogen only. So we made it for phosphorus and other nutrients. And then you can find where all the nutrients are allocated when for a long period, for example, 1 or 2 months. So in this, we can see that 21% of the nitrogen goes in the fish, 16.9% goes in the sludge. There is a big part going in the flow-out water. So this actually gives an information because all of that nitrogen should go in the plant in the best world ever. So we have to design the system in order to make to put more plants, a ratio plants fish, which is more favorable for plants. And also for phosphorus, you don't find any other thing because I mean by that phosphorus is an element that should not go in the atmosphere. It always stays in the system. So at the end, you always find 100% of the element if the work is done well. You should find it in the output. But for nitrogen, we have here 25%, that's huge, going in the atmosphere, actually, in form of gases. There it's another experiment. I couldn't put all the results, but it's just for the idea. This work has been done on a static volume of water. I mean by that that the aquaponics system has been working for 1 month, but just the RAS part. Then we took a certain volume of this water, which is very rich in nitrogen, phosphorus, and we recirculate it in the plants, but only this water. There was nothing else coming from the fish. So the goal was to determine how long it takes to epurate the nitrogen from the water, only with the plants, with nothing coming from the fish. Did you understand me well? Yeah. We made it on nitrogen, phosphorus, and other nutrients. So you can see that the conductivity is also decreasing in parallel. And this is interesting because it allows us to know what was taken from the water. And then we put that in parallel with what we find inside the plants. And so it should be the same. What disappears in the water goes in the plants, more or less. And so it was the case in this study. And then it allows us to know, okay, it was for 40 days. It's huge. For 8 cubic meter of water with nothing else coming from the fish, the lettuce growed at the final stage with no problem. And we didn't even epurate all the nitrogen in the water. It was 90 milligram per liter of NNO3 at the beginning. At the end, only 62. So this also gives an information on how to size the system. And you can easily go up to, okay, this was for 40 days. So how much nitrogen it represents, how much feed it should represent. And you can have a kind of ratio feed that you have to distribute in function of surface of plants. So we all know the ratio of Rakosi, which is 60 grams per square meter per day. in this experiment, we found that maybe it should be really lower, with 15 grams per square meter per day. It's enough, and actually we tested it in another experiment with a very low ratio, and it's working quite well also. Of course, when we compare it to hydroponics, it's always very, very low. So here you have the values from the aquaponics. Oh, sorry, it's in French. This line is what we have in the water in aquaponics, there. And this is what we should have in hydroponics to have a proper nutrient solution for plants. So this is a real question because it's working pretty well in aquaponics. And when you talk to researchers in plant science, they tell us, okay, it's not possible. Well, it is. Then when you compare aquaponics and hydroponics, and aquaponics plus an addition of chelated iron, we found no significant differences in terms of yield. And we also made different nutritional, this was on lettuce. We made also nutritional studies, and the quantity of vitamins and interesting minerals inside the lettuce was really okay with what we should expect, and it was not different compared to hydroponics.
So you mean you don't need chelated iron?
Well,
not really.
for lettuce, maybe not so much. But for basil, for example, yes, I think you need. This is interesting. It's in Brittany, so it's our partners from INRA. So here, oh, sorry, it's very small. You can't really see. But for nitrogen, for example, they have only 4.9 milligram per liter in the water because it's a very opened RAS. They have like 4 cubic meter of makeup water per kilo of feed distributed, so it's considered as open RAS. And then you can see the lettuce are just perfect. So it's really changed our way to consider the hydroponic culture, because with kind of nothing in the water, very low conductivity, you can have really, really nice products and very good yield. So this is just a presentation of the system for mass balance or life cycle analysis. We try to understand how the system works, and we implement all of this information of input and output to conclude the study. So we have to list everything coming in the system: fish, juveniles, fish, bicarbonate if we need to add it. Flocculant, it's for the sludge, to agglomerate the sludge. The energy, the water renewal, the seed spot, the substrate, and all the infrastructure. And then, with that and with all the outputs, you can make your life cycle analysis with special software. Are you familiar with LCA or not at all? Okay. LCA, it allows to determine what is the environmental impact of a production method. So we can compare aquaponics with conventional agriculture and with hydroponics and see if is it better or not so much, because it uses a lot of energy. So is it really ecological? This kind of question. Another study, it was a sensorial test. We made two tests on different type of lettuce and also on fishes, and the results are very encouraging. So, okay, you don't see much, but when it's red, but people don't like it, and when it's very green, people really enjoyed it. So this part was a degustation with people people didn't know that it was produced in aquaponics, so they just tested it and they liked it. Then we presented aquaponics and asked them if they still like it. If they are we, yes, of course they still like it. But are they ready to buy it in a supermarket, for example, or is it disgusting for us? And there is not a big difference before and after. But if we ask them if they are ready to pay a bit more for this kind of products, they are more reticent. You can see here. But it's quite encouraging.
It was people from Lyon?
No, it was...
It's a panel from Avignon City,
yes.
because the laboratory is located in Avignon City. So they have around 10,000 of consumers, and they chose some of them who are frequently eat salads.
Frequent consumers.
Yeah, frequent consumers.
But it could be different with more urban population, maybe, the reaction.
I don't think so, because there is different categories of people, young, older, students, workers, not from only Avignon City, all the departments.
After this part, do you have some questions about all that? Or?
Yes. Well, the first one, I have to go theoretical, sorry. The mass balance that you showed at the beginning of the nitrogen,
Yeah.
you say that the gas is like a lot of the losses. Were those also measured, or is it like a theoretical balance?
No, it's this part of gases is totally theoretical for the moment because we didn't have the equipment at this time. So we just conclude that the loss was going in the atmosphere because the phosphorus part was okay. We can find the phosphorus. So if it works for phosphorus, it should be okay for nitrogen, and we can consider that the loss is from gases. So the gases is in the biofilter, it can be in the fish tanks, but mainly on the decantation tank. We have a decantation tank where the sludge can stay a long time, and you can see bubbles. So I think there is a lot of mineralization inside and anaerobic activity.
In the dynamic nutrient uptake for the nitrogen, is it always on the same conditions of the other nutrients, or how was it measured? Like, is it like taking off everything at the same time, or do you replenish the other nutrients to measure only nitrate?
I'm not sure I understand the question, but
Est-ce que j'ai compris que la dynamique, est-ce que c'est la même pour les autres nutriments en fait?
does it is it the same?
For phosphorus, for example.
So let's say that you're measuring the
I can show you.
of nitrate, but I'm guessing that the plants are also taking up phosphorus from the water. So would phosphorus stay constant, or is it also?
Oh no, it's also decreasing. And yes, I can show you later if you want some documents about that. Other questions, maybe?
Sorry. Thank you. And I have a question. What about the fish feed? Also, fish feed, the main input. And also, what kind of fish feed we must be used in aquaponic system? Pellet or extruder?
Extruded pellets.
Extruder. And when I showed your presentation, there is no knowledge about feed.
I said nothing about the feed.
No.
Sur l'aliment qu'ils utilisent.
No, it's extruded pellets. Yes, a commercial feed.
Commercial. And is there any research about feed, on feed especially? Because we decide we speak only system, but feed is very important.
Of course.
And maybe oil rate and palatability for fish. And is there any study or research and information about the fish feed?
The impact of fish feed on aquaponics and the...
Yes, for aquaponics, exactly.
In APIVA, we don't really work on. Comment?
Je vais essayer de répondre.
Because
we-
digestibility is also important.
Yeah.
How much fish feed to get fish and
It depends on the species. It depends on the fish feed.
With, in aquaponic system, what is the major production do you want? Fishes or plants?
okay.
If we think this, if you want to produce fishes in RAS, it's better to use extruded pellets because to avoid some problems with the quality of water.
With solids, for example.
A few organic matter, you know, very digestible, very large digestibility of the feed. But it's true, if you want to produce high crops of plants, maybe it will be more interesting to have a different food to give to the fishes with more nitrogen, with more phosphorus inside the water.
Maybe some more limiting elements.
We don't know, we don't study for the moment in our program. Maybe somebody...
Some people are now performing research to develop special aquaponic feeds, like supplemented in iron or things like this that are not in
Magnesium
the normal fish feed.
Yes.
There is not one on the market. I think Americans invented it and went to the market like last year. We wanted to buy it, but it was too expensive to get it to Germany. But I think they use a lot of carcass from salmon farming to have more phosphorus in it. And so there are some American companies who already established aquaponics.
It depends actually. What type of fish you bring in the aquaponics unit. So it depends on if it is marine prawn you want to integrate with aquaponics, then food should be specialized, which is protein content should be high. But if like tilapia or if it is carp, common carp, then it should not need to be. It is not necessary to be high protein content. So basically, as Catherine said, that it depends on what product you want, either fish or plant. So if it is plant, then you need to just think about the balance in between the fish releasing and the plant taking. That's it.
Have you done any research into companion planting for aquaponics? It's quite interesting to see that there's so much nutrient left in the water. So, as we do in soil-based agriculture, having plants that take different nutrients. I don't know. I've not seen any in my research anyway. Properly down the road of companion planting. I don't know if you guys have done any in the past few years, or if you just focused on lettuce at this point in time.
T'as compris?
Very quickly.
C'était juste sur la
You know, it's the afternoon.
Yeah,
So-
I apologize.
planter d'autres plantes qui vont peut-être
in
prendre parce qu'il
soil-based
reste encore
agriculture,
beaucoup de
there's-
nutriments dans
Des plantes qui seraient plus axées sur la phytoréparation.
We have
Voilà,
our
accessoires,
translator.
diversifier un peu la production pour
See this scheme. It's from our partners in INRA. They use not only aquaponics system but also phytoreparation process before the aquaponics part, because it's a big system. They have a lot of sludge, so they divided their effluent in two parts: the highly loaded water, coming with the flush water from the tanks. They put that in a sump tank. Then they take the most part in a sludge mineralization bag, techno bag, and another part which is also loaded with solids, suspended solids and nutrients. They put that in the vertical filtration for phytoreparation, for a better phytoreparation. So we have how do you call this kind of plants? In planted wetland, you know.
Oh, okay. Like
Such
grasses.
wetlands.
Yeah, it's this kind of plant that they
Right,
use.
okay. But in terms of edible food.
In
No,
terms
no.
of edible food, no, we
No,
don't really try the companion plants. Have you?
Not in aquaponics, no.
Okay.
Just wondering if there was any research into it.
No, we just try to size the system in order to have the proper amount of plants to take all the nutrients. But as you can see in the mass balance, so it was the first try of mass balance. Since this time we have done 2 overs, but we have to treat the results. You can see there 0.7. It's the part of nitrogen going in the plants. That's very small. When all that should go in the plant, 35%. So there is work to do to understand really how much you should put your ratio to have a proper
Pierre,
phytoepuration.
What is your flow out water precisely?
The flow out water?
Yes.
It's the water going out from the system, because it's not totally closed.
So around 300 liters.
It represents 2 cubic. It depends on the time, because it's in function of the quantity of feed we put in the system. But it's 300 liters per kilo of feed, and at this time it was a 2 cubic meter per day.
Did you test different flow out rates? So if you slowed the water down, did the lettuce absorb more of the nitrates?
We actually tried, yes, different rate of makeup water, but the problem was the pH. If we don't put enough water, the pH is going down very, very, very fast, and it consumes a lot of bicarbonates, and it's quite expensive. So we should find a compromise. And if we put too much water in our system, because our water is very hard, a lot of Ca inside. So we put 300 liters per kilo because it was the best for our system, because of the alkalinity of the water. But if we put too much water, the pH is too high. If we don't put enough, it's too low.
300 liters per hour?
No. Per kilo of feed per day.
Oh, okay.
So if we have, I don't know, 5 kilo of feed, we have 1 cubic meter per day.
But it was a continuous flow or just interval flow?
Continuous.
Continuous.
On a day, 300 liters during the whole day.
If it's 1 kilo of feed.
For each kilo of
For 5 kilo, it's 1 cubic meter per day. Yeah.
And sorry, I don't understand why you use phytoepuration plants.
Why?
Yes, instead of taking the mineralized water back into the system.
Actually, we don't have a mineralization tank for the moment. We haven't made any studies on that, but we want to do that, but we haven't tried yet. We only use techno bag, bags to filter the plants, or vermifiltration. But for example, for the moment, we don't know how to mineralize sludge. We haven't tried.
So you put the plant land?
It's a first process of epuration to have less suspended solids inside the aquaponics part. Okay. Because before they added this complement, they had too much suspended solids because their water is very full of organic matter, even if there is a drum filter.
What is the initial pH of the water?
It depends. In this system, in Brittany, which is in an open environment, the water is at 6.5, so it's very, very low. But at Rato, the water is at 8.5. So, yeah, depending on the alkalinity of the initial water, it's really different. Because at INRA, they use like 3 or 4 kilos of bicarbonate per day. So
it's quite a lot.
Yeah, it's quite a lot.
Quentin, t'avais pas une question?
Yes, but I can wait because I'm running.
Okay.
Okay, so did you try for what you did with the consumer with the lettuce? Did you do that with the fish?
Yes, we did.
What was the result?
So I don't have it here, but the results were also very good. It was a rainbow truth at this time. Okay. Actually, we were surprised because we tested the product ourselves, and because we really know the product, we were able to feel a bit of off flavor. But the consumers didn't actually. They found the taste really nice. So.
Yeah, because I've seen a study where they're saying that there is a molecule that is produced by the plant.
Geosmin.
Yeah, that's what it is.
By the bacteria.
Yeah, okay. So
And
then it's actually, you can taste it in the flesh. So.
yeah, that's the problem with very closed RAS. In INRA, they don't have any problem with the off flavor because it's open RAS. They put enough clear water per day to wash the fish, but it's really close because they have 4 cubic meters of new water per day per kilo of feed, and in a conventional system it's 100 cubic meters, so it's closed, but not so closed, and it allows to have less off flavor, but it consumes more water. But in closed system, yes, you frequently have an off flavor problem, and at intensive fish farm, they have to rinse, to wash the water in a washing tank for 1 week or more with clear water to take off the taste of the flesh.
What is the name of the bacteria again?
The name of the bacteria, I don't know. It's
Cyanobacteria.
Cyanobacteria, okay. And they produce geosmin.
What is that? Geosmin?
It's a molecule produced by some cyanobacteria.
No, isn't it?
Maybe.
Which is produced by special algae, cyanobacteria. But you know, it's very common in pond fish farming. But it's not a real problem because, as Pierre says, it's possible to clean the fishes. You put them in clear water during 2 days or 3 days.
During harvest, basically.
Yes, without feed, of course.
It works more or less regarding the species. Tilapia and rainbow trout, I think it's quite okay, but some fishes like sturgeon keeps the smell, the flavor a long time.
You know, with Lionel, 2 weeks ago, we have gone to visit the Nerbrain company in Ondarribia.
Spain.
Irún, near Irún, in Spain. And it is a large company, aquaponic company. They want to produce 50 tons of tilapia. They have 4,000 square meter for greenhouses and around 2,000 square meter for fishes. So a large one. And there is 2 RAS, and they have designed a large tank, very large tank, with clear water for tilapia before to kill them. And they have to stay 2 or 3 days inside before to fillet them. Okay. So it's common in aquaculture, in RAS. You have to clean the fishes.
Yeah, I know the practice, but I didn't know why.
Yes, for this reason. You know, maybe it's from cyanobacteria, but maybe also it's from pellets. Also.
And other heterotrophic bacteria also,
Heterotrophic
which
bacteria.
are consuming the sludge, the little suspended solid in the system. The big problem is that we have a mechanical filter, but it's only 60, usually 60 microns. Micro. So there are a lot of particles which are much which can go inside.